I also want to acknowledge my colleague and co-author, Svetlana Tihomировой of Vladimir State University, whom we co-directed this project that we're going to share with you and research. So this is just, I want to right up front to say that for this project, we're presenting just preliminary results. We collected a lot of data, which is still in the process of data analysis. Make sure. So just a quick background. Technology, we just heard to a plenary by Sergei Nikolaevich Pozdnyakov on the role of technology in teaching mathematics and how our understanding of what to teach and how to teach is changing as technology comes into play. So there is a lot of research about the necessity to use technology in teaching mathematics and nowadays. The fact that it's teachers who need to know how to use technology effectively, what is critical for us when we teach mathematics to the students. And the part, what is really important is how do we prepare teachers. It's probably very hard to change what our veteran teachers think, especially if they haven't had experience in teaching of technology, but our real focus should be on teacher preparation and getting those new teachers to be open and to technology and also being able to use it effectively. So what we know, this project is dealing. Oh, yeah. Sorry, I'll try to slow down as much as possible, but sometimes it's just really hard to think about it. So we know, at least in the United States, that we do not prepare our teachers, future teachers, to teach effectively with technology. There's a whole bunch of abundance of research which shows that. And there are a lot of reasons to that. We also know that in most countries, in most universities in the United States, in a lot of other countries, there are different ways technology is introduced in teacher preparation programs. Some universities, it's just a single course where students learn, and it's technology education course. They learn about technology in general, and it's not connected to subject-specific knowledge. There are much fewer programs where technology is integrated across curriculum so that students see use of technology through their own courses and experiences while they're learning mathematics. And then they also experience technology as part of their teaching methods courses. Unfortunately, again, it's the same. The research shows that as we look at the college faculty, they're also very conservative in terms of use of technology. So our future teachers do not have experience of being in a classroom with technology being used to support content development. For this particular project and for this research, we've used TPAC framework, and this is a fairly recent theoretical conceptual framework. TPAC stands for technological, pedagogical, and content knowledge. It's an extension of Schulman's PCK, pedagogical content knowledge framework, which pretty much says the following. We can have teachers, like PCK, idea of PCK, pedagogical content knowledge. If our teachers know content, mathematics, and know pedagogy, how to teach, it's not enough for them to teach mathematics. The knowledge how to teach mathematics effectively is an additional knowledge, which is not just simple addition or simple sum of two different types of knowledge. What this particular framework suggests, and it was offered in 2006 by Mishra and Kohler, that the same goes about technology. Just to know how to use technology and to know how to teach mathematics is not enough. We need to know how to implement effectively technology into teaching mathematics, and that becomes a very new knowledge. And we have to teach that knowledge. We can't just assume that we taught the teachers, they're prepared to teach mathematics. Now let's put computers in their classrooms, and they should be able to teach mathematics with computers. So, in this particular project, we received funding to try to work with 10 student teachers from our university, College of Staten Island, that's a part of City University of New York, and 10 student teachers from Vladimir State University. All of these students were preparing to teach in elementary schools. You can see the demographics. So as you could expect, like in those elementary school preparation programs, majority are females. So all our 20 students, 20 participants were females. The interesting comparison here, you may notice that the American group was more diverse in terms of the ethnicity, in terms of the age, and for American groups, majority of them were first-time college students in their families compared to Russian students. Again, that represents the demographics of the region, probably more than anything else. It was also important for us to compare the programs that were offered to both groups of students in order to select content that was overlapping. So if we look at the amount of hours that they spent in mathematics courses and pedagogy courses, they are pretty much the same, very similar, very close. However, the content courses are very different, as well as for mathematics content and the pedagogy courses. One of the specifics of American system of education that doesn't matter what program students enter in, they take general education courses. Means all students for different professions have to take particular number of mathematics courses. And if you notice, those mathematics courses usually cover like analogy of high school courses in like Russia. So for Russian students, most of their content preparation was focused on elementary school curriculum. For American students, half of their content was focused on more like algebra, pre-calculus, which is like trigonometry, and is shown here, like college algebra, trigonometry, and only half of the courses were focusing on the content specific for elementary school curriculum. Oh, did I press? Yes. In terms of, so we've selected geometry because that was most aligned between two programs on one part, and also it was a topic that we both, me and my colleague, believe that very important in elementary school curriculum and very often gets overlooked and pushed out of the curriculum for different reasons. So our research questions were first, like whether our project will have any effect on our pre-service teachers, and also to compare how American and Russian students compare in their knowledge of mathematics, knowledge of pedagogy, their relationships, attitudes towards mathematics, technology, and in this particular project, we have collected, it's a mixed method research design. So we've collected a lot of quantitative, qualitative data. You can see here that the data included geometry, knowledge test. We had surveys on attitudes in mathematics and computers. We had them to actually have a journal on how they introduced Geogebra, that was our technology for teaching geometry, how they introduced Geogebra into their class, like over a period of about 4 to 6 weeks with their students in the practicum. They've developed lesson plans. We asked them to video those lesson plans. They collected student work for analysis. They had reflections, write about their personal experience in learning technology, about their students' experience. We also conducted some interviews. I'm gonna go quickly. So geometry test, well, we decided to give them a fourth grade test in geometry, which their students would be getting. It's a test which developed by a National Association of Education Progress. So just give you examples of the questions that our test was focused on symmetry and properties of polygons. So this is just, it's consisted of some multiple choice questions and constructed response questions. So this gives you example of a multiple choice question and a constructed response question. The math attitude scale is an instrument which was developed by Kadler and Lessig, fully validated instrument, and it was assessing several parameters such as confidence about mathematics, anxiety, value, how much they value it, enjoyment, motivation, and teacher expectations. So this gives you examples of the survey items. And so it was another aspect of our analysis in terms of comparison between the two groups. Attitudes towards computers, again, that was another survey, several different scales within that surveys, fully validated instrument. I'm gonna go through this quicker to get to results because time is running real fast. I think those gears, you know, and time, like ratio is now not 1 to 12, but like 1 to 5. So survey analyzed the interest towards using technology, computers in this case, but by computers we mean like technology, digital technology, comfort, accommodation, how well the interaction important in the classroom, any concerns, whether computer could affect their own productivity, which is utility. Their perceptions was on semantic scale, everything else was on Likert-like scale, and significance. TPAC level rubric is an instrument which I and my colleague developed a few years back. It's been used quite widely now worldwide. And it's really how to assess effectiveness or quality of teaching of technology in a specific subject. So it has 5 progressive levels of technology implementation, integration in 4 different components, which progressive levels is really that whole idea of integration of PCK and technology at like 0 level, right? Like pretty much they're separate. I know I have my smartphone, I know how to use technology, and I teach mathematics effectively, but they're not connected. And then it's kind of, if you think about it visually, integration of technology, going from understanding that technology is there, recognizing that it needs to be used, making decisions about where and how to use it, to the point where technology is changing the way you teach particular mathematics. So these are these 5 levels. And I'm going to be skipping here. And it's a rubric, so what you see here, where numbers are, it's really criteria. There's 2 criteria for each cell of the rubric, for each of the components, which define teacher actions and student actions, what you would observe in a classroom in a particular level. So the project itself was pretty short. A number of participants small because it was limited by the funding that we received. But the idea was that we provided our teachers, our students with, we collected baseline data on surveys and geometry tests. We had 4 weeks of working with them together over Skype, and then we've collected more data, and also like our students taught lessons and collected data from their classrooms. So gives you a little outline. Of course, we needed to introduce the Geogebra to the students. We also needed to introduce ideas of pedagogy, principles of effective use of technology, some ideas in geometry. And we met every Saturday for 2.5 hours. It was 10 a.m. our time, it was 6 p.m. their time, but it was together with the Russian and American students, and we had an interpreter which allowed communication and delivery of the information. So at the last session on Saturday, students micro-taught their lessons, like short excerpts of their lessons to each other and got feedback from each other. So this shows you like how it looked like. So there's like a screenshot, like these are my students on one side and Svetlana's on the other side. And they met in a computer class. Our students brought their own laptops to each session. So Geogebra was introduced as a tool to provide discovery type of activities, inquiry-based activities for the students. So first we had like immersion experience where we got our students into that immersion, experience it, and then we taught them how to use it, and then we asked them to develop their own lessons using Geogebra. And that's just very brief outline of what we're trying to do. So we had 10 students on each side. They were assigned to particular grade levels in the schools where they were student teaching. So we combined them in small groups. We had, in American group, we had several teachers teaching grade 2, several grade 4, several grade 5. I put ages so that you see correspondence age-wise. So in Vladimir State University, it was grade 2, 3, and 4. But pretty much one grade, like grade 4 in America corresponds to grade 3 in Russia. And this shows you the topics that our students selected for their lessons. So they collaboratively developed lessons, but they taught it individually, and some made adjustments based on their classrooms. In the Vladimir State University, they have one school that they work with as their student teaching practice. In the United States, we have in our college several different schools, so students were in different schools when they were taught. Well, we probably wouldn't have, let me try, maybe we will have time. I just want to quickly get your idea. So this is...
With the help of this tool, we construct the right triangle.
You guys construct it?
Yes.
Выбираем инструмент «Перемещать».
We choose the move tool.
С помощью этого инструмента выбираем одну из точек треугольника.
Just to give you an idea, so what's happening right now that Russian students are micro-teaching their lesson. There is an interpreter, and my students are sitting in the classroom and repeating what they're told to do, so that like they experience the lesson. Then there is a whole like feedback going on after that, and then we did it like grade by grade. So and then well, I'm not a Mac person, so let's see if it works. And so then after feedback, that you would like there would be
Геометрию ученики будут создавать как бы половинки своих монстров. Ноутбук сосед на экране.
Then you are then going to select the line tool to create a straight line, and that will be your line of symmetry.
So now it's a micro-teaching on the other side.
Теперь у нас инструмент прямая используется, и мы с помощью этого инструмента.
We don't have time to like really like fully see like, but there was a really nice and rich conversation. So if you're interested, I'll share the videos. The videos are much longer than I could possibly show here. So, and then this I do want to show very short clips, excerpt from the classroom in American classroom and excerpt from the Russian classroom, because it shows you really big difference in a way the school set up and in a way students taught. So this would be American classroom. So I'm going just to talk over this. So what's going on is that in American classrooms in elementary school, you will see kids sitting on the floor, on a rug, and working together on the tables, and teachers usually not in front. Teacher walks around, there are stations, and so in this case, the students are working on a task. They have the handouts, which tells them what to do, and teacher walks around, makes sure that they're working together in small groups, and they're understanding what they're doing. So, and then here, like, she's scaffolding her student, like, specifically that boy who's not sure to understanding what kind of properties to look for. She keeps scaffolding him until he comes up with understanding, oh, it's about like angles have to be the same or something like that. So in the Russian classroom, it's more like, if you look at it, more traditional settings. All students have their computers here on their desks. And for some reason, on this computer, it's not playing, but it was playing on mine. So I don't know what's going on. It's a slightly different format. But anyway, so the teacher is up front, and she gives a really interesting task for the students, but she's up front, and the students at their desks, and it's a very different dynamic and a classroom atmosphere here. So where we are in this, so we wanted to understand, like, and compare, and as I mentioned, we are still in the process of analysis of qualitative data. We looked at quantitative data, and I just want to say I'll present some statistics, but there is no real statistics of this small sample, but it just gave us an idea what kind of questions we want to ask if we would like to scale up or extend this project. So we did some pre-post test analysis on geometry, attitudes towards math, and towards computer surveys. grades and used like t-tests for that particular reason, paired samples t-test, and then independent sample t-test when we compare two groups to each other. And so for geometry, it's a whole group. Well, if you look at it, you will immediately see that, really? Can I, a little more? So you see in the geometry test, there was no difference between pre and post, which is expected. We really didn't teach them geometry. We were trying to use geometry to teach them how to use Geogebra. But at the same time, if you notice that here, Russian students pretty much aced the test. The maximum was 32, the average score is 31.7, right? So, of course, there is no improvement. I mean, they were already perfect. The American students, on average, missed about 4 points on a test. And so this is kind of shows you 10 students and the difference. And these are 3 questions where they had most difficulties. If you know that, like, this is multiple choice questions where they just half of them answered it correctly, deals with just understanding of parallel lines and transversal. Based on a word description. So it's conversion from word description to the visual. This was a constructed response question, again, really focusing on conceptual understanding of shapes and properties of shapes in this case. They had to draw a line through the 3 different squares to show 3 different possibilities to create quadrilaters. So they had a hard time to get 3 different. All of those were kind of the same. And the last question was dealing with perimeter of rectangles, but it's like there is a little tweak here. So which, again, explains us, we know that the content knowledge of students in Russia and requirements to content knowledge are much higher than requirements to content knowledge of elementary school teachers in the United States. One of the things we have to work on. On attitudes, it was interesting that the attitudes didn't change. Our project didn't affect on their attitudes statistically, which again, there is no statistics, too small sample. However, what was interesting is that we had very strong correlation between different components of attitudes. And when we compared the attitudes, then on American students, there were no correlations between different categories. All the correlations came from the Russian students. So in other words, if they had a really strong attitudes towards mathematics, it was across all the parameters. For Americans, it was like no correlation whatsoever. Significantly high anxiety level for American students compared to Russia towards math. And the significantly stronger belief in value of mathematics on Americans than Russians, which was surprising. But I think it's this whole testing, which pressures on them that they have to get math for their students done. And the other thing which was very interesting, our students had significantly higher concern about what their teachers think of them in terms of mathematics. In other words, that whole perception of what my teacher thinks of me was affecting them much, much larger than Russian students. Attitudes towards computers, American students had much stronger attitudes towards computers and use of computers in the classroom than Russian students. And pretty much on 6 out of 10 scale item, they showed significantly higher situations. Now, when we looked at the PAC levels, like effectiveness of using technology in a classroom, right, for teaching mathematics, we had same number of very low performing and very high performing, like effective and ineffective use of technology in a classroom. But in the middle, that's American students did a little bit better. Again, on average, it's about the same, but since we only had 10 students, we compared them like this way. I'm skipping that, sorry.
It is a great program, mathematical.
So the reflections we collected, well, Americans write much more than Russians. That was surprising. Like Russian students wrote like 1 sentence or said, I have no comments. And American students wrote like half pages about how like discussing different teaching strategies was really great, and that they really enjoyed learning from Russian students about their like teaching and so on. And like every single say, like, I would like to thank for this opportunity, you know, like in the comments section. So it was interesting. I think it's a cultural difference between American and Russian students in this case. I also like this comment from one of US participants that this particular project opened her eyes on how to teach mathematics differently and how that helped her to feel more confident in her own mathematics because of teaching with technology. We asked them recently, like it's 2 years after, what they think, we had a very great response from one of the Russian participants who said that she's using it constantly, that her students installed the software at home, and that completely changed the environment and interest in mathematics in her students and herself, and that they're learning so much more that before they couldn't understand. And we see the same thing on the American side, like they're really using it, they're enjoying it, and they feel like this helps them to teach mathematics to their students. This particular student...
I think it's a shame that oftentimes technology is used as leverage in the classroom, meaning if the children behave, then they are granted technology. So I think it's a shame.
So this particular student actually pretty much went in a much bigger picture about technology has to be used, not just as a word, but as a tool for teaching and learning. Svetlana and I put all the materials we developed, and we developed them more. So we have developed those books, which was part of the grant, teaching manual. Like we have 32 lessons with explanations and everything that could be used with Geogebra. And if you're interested, we have a couple of copies of the book with us here in Russian and in English, and some CDs of those materials. And if we don't have enough, we can send you PDF of materials. So it's 32 lessons over curriculum, a whole curriculum from grade 1 to 5 or 4, depending on the country. And just want to mention that we're still going, it's more qualitative probably, and qualitative data take a lot of time to prepare and analyze. We definitely have very small size for the sample and very short time period. But I think we found very interesting questions that we can ask in any further collaborations. And the other thing, which we also noticed, health regulations, laws in Russia, which don't allow kids to spend more than a particular amount of time on computers, significantly limited opportunities for Russian students to incorporate technology. But all groups found that this kind of collaboration brought something new and very important to the everyone. Thank you very much.
Yeah. Thank you very much for this very interesting talk. I think it was worth every second. So now we have time for a few questions, 1 or 2 maybe.
Yeah, thank you. Actually, my question is just about Geogebra as a tool for very elementary education, and I have kind of concern if you compare that with traditional tools like chalk or something. And one important feature of this traditional tool that it connects this mathematics to real world, so to speak, right? And if we replace it by this simulation on a screen, kind of designed by other people and on principles which students don't really know, it's kind of complete, erasing the difference between this virtual world on the screen and kind of real world. And wouldn't be this kind of problem in education, in your view? Okay, thank you.
Okay, so I'll pick the... First of all, introducing of technology like Geogebra into classroom does not mean that we take everything else away. They still have real world, they still have physical manipulatives, and we didn't have a chance to show, but if you see one of micro-teaching lessons, the students started to folding paper when talk about symmetry, looking at the pictures before they got into the software. Second, the Geogebra recently updated software, and now some of the apps became separate and not big package. So the geometry is a separate app, which is very user-friendly and appropriate for younger children. I wouldn't use Geogebra Classic with elementary school children ever, because it's just way too complicated and too confusing. And the third thing is that it's used in a sense as a drawing tool, where students can make some measurements, can observe some things in a friendly environment, and when they use touch screens, it becomes very natural to them. Our children are not what we were. They are touch people, They automatically know how to do this and that, and that particular tool become that friendly with the touchscreen's usage, and kids feel very comfortable. I agree that they may not know what's behind in terms of the ideas, but we don't teach them in elementary school as much about like, oh, prove, justify, right? We want them to explore. So the activities they did here, they saw folding, right? So we kind of model that folding after they did it physically, but then they were able to dynamically change, and I'm again going back to what Sergei Nikolaevich was talking about. They were able to change dynamically, so it's not just one shape they cut out of the paper, but now they can create different shapes and see how they're changing in that reflection. So that's the richness which it brings, like from one example to many, but one physical example to many on a simulation. Does that make sense? Okay. Да. Вы скажите, я вас переведу. Комментарий я переведу. Вот там. Ну да, например, с точки зрения русских.
Hi, my question is very small detail about the limitations and the Russian regulations. What is the exact amount of regulations? How much they allowed to have screen time and under which period time?
Каковы ограничения на использование компьютеров в русских школах?
По времени каждому классу.
Ты говори, я переведу.
По времени на начальной школе. Сейчас, кстати, последние 2 года изменились санитарно-гигиенические требования от 5 до 10 минут, и на 4 класс к 15.
Within one lesson, up to first through third grade, да, с 1 по 3? First through third grade is 5 to 10 minutes maximum in a lesson, and a 4th grade, 15 minutes.
За урок вообще, то есть 1 минута, потом перерыв 2 минуты или сразу 5 минут.
Is it defined by the one lesson?
Per lesson.
Can't connect them together for the
Можно ли их добавить все за все уроки в один урок?
Внеурочные занятия, да, конечно, 1 час в неделю.
After, like in after school, they can do 1 hour per week, and sometimes what they do is they combine them all as 1 hour, but it's done after the lessons.
Как обучающий курс, да.
And that becomes a separate. It could become a separate, like a course for them.
Что участники проекта и делают.
So in our project, the Russian students, some of them did. They just combined those in one extended block in order to do this project.
So what about the homework? Do they have computers with Geogebra at home also in Russia?
У детей есть дома компьютеры? Могли они дома работать с этим?
Да. И компьютеры, и другие
носители. Yeah, they had computers and other technology platforms.
I think maybe it's time for lunch now. So let's thank you again for this interesting talk.
Thank you very much.
Спасибо.